Good evening, one and all. Welcome to ACE Engineering Academy, ACE Online. Guys, yesterday, what we have discussed regarding the strategic preparation for GATE and ESC for network theory topic. Today, I would like to take under network theory subject some of the important concepts which are very much useful for GATE and ESC under network theory subject. Under network theory subject, yesterday we have discussed so many topics are there. Under that very important topic, one of the most important topic, which is the transient circuit analysis. Today, I would like to interact with you by giving some of the inputs regarding the transient circuit analysis. Now, I would like to start with the transient circuit analysis of introduction as well as the classification and how the classification DC transient and AC transients and some of the important concepts I will discuss. First 40 minutes because we are having 1 hour duration. That's why I would like to take this, or I would like to divide this one into 2 parts. Number 1 is the theory part, which I am going to give the inputs to you regarding the transient circuit analysis topic. And after that, definitely we will take the questions related whatever the discussed under theory part of transient circuit analysis, right? Let me consider that the introduction of transient circuit analysis. First of all, when you are getting the transients in the electrical circuits, usually in general you can take the transients which are happening in any system. Suppose if you consider in electrical systems when the disturbance occur, or simply in electrical terminology I can take it when the fault occurs. Usually 2 types of the faults you may identified in electrical circuits or electrical in power systems, open circuit faults and short circuit faults. Usually short circuit faults are existing, open circuit faults are uncontrollable. That's why the short circuit faults are there. Right. Apart from this, while coming to that, in general, in electrical transients, as per the network theory subject, I can say that we need to provide some excitation with sudden changes. Right. Now, we have to take for transient circuit analysis, the network should be identified 2 things. Number 1 is sudden changes. Number 2 is energy storage elements. Energy storage elements. If these 2 are identified, then only there is a possibility for transient circuit analysis or transient response can be happened after the sudden change will occur. Now, let me consider that some of the important points under this transients or electrical transients or transient circuit analysis. The first one, transients in the electrical circuits is due to only with the effect of energy storage elements. Why? Because the energy storage elements, the energy does not change instantaneously. Energy does not change instantaneously. Suppose if you consider for inductor energy is for magnetic field. Magnetic effect you may identify in general, magnetic field effect does not change instantaneously. Instantaneously means within 0 time, right? Now for the capacitor, within 0 time is nothing but what? Instantaneously. Due to the integral dependence of the memory variables which are inductor and capacitor. Usually we are considering for inductor, the magnetic field is directly proportional to current passing through that. For capacitor, electric charge is directly proportional to applied voltage. That's why, remember guys, whenever if you consider that energy variables for memory elements, for inductor in terms of current, for capacitor in terms of voltage, right? Because psi is directly proportional to I, Q is directly proportional to V. And one more thing, once you are providing the sudden change, then only we are getting that. Then the next one is the network contains only resistors. Suppose network is not having any energy storage element. You will not get any transients. Even though switching action is provided, nothing but what? Sudden changes are provided. Even though sudden changes are provided, you will not get any transients after sudden changes when the network is with resistors only, pure resistors, only resistors are present. Since across resistor, current does change instantaneously, voltage does change instantaneously, which is not happening under memory elements as per the memory value or memory variable. Now, transients, the third point, see this, transients are more effective for DC than AC, and also transient free response is possible for AC excitation. Here, main thing, if you want to study the transient response, definitely we need to take that here within the time, how much the time duration for the transients, because transient effect is after sudden change, the duration for that one to study the transient response, we should have a finite time, or in DC excitation, you know that for DC excitation, the time period is infinite, and AC excitation, the time period is the finite. Suppose if we consider that for AC excitation 50 Hz, the time period is only 20 milliseconds, while coming to the DC is infinity. That's why we are able to analyze, we are able to study transient as well as steady state responses clearly for DC excitation. Guys, in AC excitation also you will get transient as well as steady state, but the effect of the transients are very less for AC excitation because the time period for AC excitation is only 20 milliseconds. Within the 20 milliseconds, if you want to study the transient response, it may not possible. That's why the effect of transients for DC more than AC. And the question related in AC, in GATE or ESC examination on AC transients, you may have only the possibility condition for transient free response, condition for transient free response. Right? This is the only the possibility under AC excitation, under AC excitation. Right? Now, if you take that for any excitation, either AC or DC, with the sudden changes, the response is transient as well as steady state, transient as well as steady state. Suppose if you consider that, let me consider here for DC excitation as well as AC excitation. Suppose here for DC excitation, if I take that, and here AC excitation. Now for DC excitation, I will consider that for DC excitation, suppose this is the DC excitation and this is the AC excitation. Now the excitation, you can take it like this. DC excitation means what? You will consider that DC excitation is DC. This is the DC with 10 volts or 20 volts. And while coming to that AC excitation, suppose this is the input, and AC excitation means what? We need to consider like this, the sinusoidal waveform. Yes or no? This is the sinusoidal waveform with a maximum value of either 50 volts or 100 volts minus 50. Now how the response for this one? What is the time period here? The time period here we are getting, this is the time period for this one, 20 milliseconds. Sir, no. Here what we are getting, the time period is tau is equal to t is equal to infinity. Here we are getting that. T value is equal to infinity. Here t is equal to, for 50 Hz, 20 milliseconds. For this one, definitely you will get for those both here. Both you will get it for this one. Transient and steady state. Both you will get it. One response with the excitation, with the sudden changes, definitely after sudden changes, you will get it. Transient as well as steady state you will get. Both you will get it. Now let me consider that how it is. Here we are getting after sudden changes, transient and steady state. Here we are able to define that the response which is varying with respect to time. Usually we are considering up to 5 tau. This response is nothing but the transient response and this response is nothing but the steady state response. Is it right? While coming to that here also you will get the transient as well as a steady state. But see this one, how it is varying with respect to t. It may be depending upon that. Here we are getting for each cycle transient as well as steady state. Here you can identify, up to this, whatever the response which we are getting, this response is nothing but the transient response. After that, this response is nothing but the steady state response. Once you identify both the cases, guys, in this one, transient response can be studied. In this, transient response is very less. That's why the effect of transients for AC is very less, and transient free response is possible for that one. But while coming to that, effect is more for DC excitation. That's why we will consider, or the questions in GATE or ESC examination, more questions are coming on DC excitation, right? For transients. Now with this we can define that what is the transient response and what is the steady state response. This is the definition we can take it. Transient response, the response which is varying with respect to time, that is the transient response. The response which is constant with respect to time, that is nothing but the steady state response. Let us take that the classification. While coming to that the classification, based on the excitation, the classifications can be taken into two ways. Number one is DC transients, number two is AC transients. Under DC transients, guys, again you can take it DC transients in three. Number one is based on the excitation or based on the order of the system, we can take it again two. Number one is first order circuits, number two is the second order circuits. And while coming to the third part also, we will consider with the special cases whenever if the response is impulse response or excitation, then those circuits can be handled with the Laplace transformation, because there is a violation of KVL and KCL. That's why under transients, the major portion are divided into three parts. Number one is first order circuits, number two is second order circuits, number three is the special excitations or special cases when the violation of KVL and KCL are existing in the network at t equal to 0 plus, then the response or excitation may be or impulse response, you may get it that. Now while coming to that, the first one, first order circuits, under first order circuits, again you can take it into two categories, source free circuits and with source circuits. First one is source free circuits and with source circuits. You know that source free circuits means inductor should have initial current and capacitor should have initial voltage. It has to be defined. It has to define, or based on the switching action, we need to be estimate the initial value of inductor and capacitor. And with source circuits means usually source free circuits, with source circuits, the main difference is whenever if it is source free circuits, the inductor and capacitors are having the response functions or decaying functions, since they are acting as temporary sources. While they are acting as temporary sources, they are decharging. According to that, the values of inductor current and capacitor voltages under steady state 0, you will get it. Decaying functions. While coming to that with source circuit, rising functions you will get it, because they are charging, right? And the second order circuit, suppose if you are considering that, usually second order circuits means if the network contains RLC 3 elements. And while coming to that LLR means these are not separable. Separable means what? Suppose if the inductor, two inductors are like this and resistors are like this, then these are the separable. This we can separate. How can you separate this one? This we can separate like that inductor part and resistor part. Suppose if the network contains like this inductance, resistance and inductance and resistance. This will come under second order circuit which are not separable. If you see that here S, R, then definitely you will get the total transfer function, second order function you will get it. Like that I can say that here the CCR or RCR which are not separable for resistors and inductors. Nothing but what? If you are not able to define that time constant as like first order function time constant, you are aware of that tau is equal to L by R or L by R equivalent for RL circuit. You can take it for RC circuit R into C or equivalent into C equivalent. But for the second order circuits, time constant based on the response, if the response may be underdamped, overdamped, critically damped or undamped case, with these four cases we can define the time constant of the second order circuits, right? That's why here in this one we will take the two parts. This is very important here. Compulsory question you will get in the second order, responses at t equal to 0 plus and t equal to infinity. This is the very important concept. You should practice more examples under this one. And while coming to that responses for t greater than 0, it will take so much time under time domain. That's why definitely we need to go for Laplace transform analysis. You may get a doubt, sir, why can't you take that here first order in Laplace? You can also take, but there is no difference between that. That's why Laplace transform we are considering. And finally, special cases with special excitations like impulse. Impulse excitation is there. Under that time, you should go for that Laplace. How we need to deal the circuit, that also we are going to discuss. Under this AC transients, you need to get it the transient free response condition. Transient free response condition. Under transient circuit analysis, the questions under gate examination or ESC examination, only these topics, if you are perfect, definitely 100% marks you can get it in gate or ESC, engineering service examinations. Now let me consider that first, how the sudden changes will be provided for any circuit using the switching action. This is very important here. So how the switching action we are to be affected, we need to be considered for the electrical circuit under sudden changes conditions. Let me take that. Here, based on that only we can take the circuit either source free circuit or with source circuit. Now let me consider this. Once you see that the first one is, based on that switching action, I am able to define this network is related responses in this network. Finally, if you want to get the responses in this network, based on the switching action, I can say that this will come under with source circuit or source free circuit. Now, according to the direction of the switch, you can say that as per the direction of the switch is closed at t equal to 0. Nothing but for any transient example, we should be define the switching action before t equal to 0, after t equal to 0. Now for t less than 0, for t less than 0 and for t greater than 0. This is important. Now for t less than 0, then definitely I can take it whenever if it is t less than 0, switch position is what? It is opened. S is opened. Once S is opened, is the inductor capacitors are affecting with the source? No, they are not affecting. That's why the values of inductor and capacitor, initial values are 0. That we have to be consider. If it is given, even though this circuit is given, inductor initial value, capacitor initial value is given in the examination, then those values to be considered. Otherwise, the response is starting here. Initial values are 0, inductor current and capacitor voltage. If it is given, then we need to be start here, initial value as I0. Right? Now, according to that, I can say that if the inductor current and capacitor voltages are given, you have to be considered. Otherwise, it will start at t equal to 0. They are not having initial values. Now let me take that after t equal to 0. After t equal to 0, switch position is what? Closed. Once the switch is closed, is the inductor and capacitors are affecting with the source? Yes, they are affecting. That means what? Are they charging or discharging? They are charging. How they are charging? They will not charge suddenly, because sudden changes are provided. Instantaneously you will not get it that. It will take some time. That's why the response whatever we are getting after t equal to 0, either inductor, what is the state variable for inductor? For an inductor, state variable is the current, and capacitor state variable is what? Voltage. Now you are getting that response is transient as well as steady state. Here inductor and capacitors both are charging. Both are charging. This is with source or source free. Always we need to be decide the response after t equal to 0 based on the response after t equal to 0, or based on the circuit after t equal to 0, we can decide the network will come under either source free circuit or with source circuit. This is with source circuit or source free circuit? With source circuit. Because after t equal to 0, we are having that source, inductor and capacitors are having source with source circuit. And while coming to that, the next one is what? Source free circuit. How you say that? Till t equal to 0, switch position is what? Closed. Here also we need to be decided for t less than 0 and t greater than 0. For t less than 0, you know that switch position is what? Switch is closed. Once the switch is closed, is the inductor and capacitors are affecting with the source? Yes, they are affecting. Here inductor and capacitors are not affecting, no source. That's why no initial values. But here before t equal to 0, here after t equal to 0, inductor and capacitors are affecting with the source, that's why they are charging. While coming to that, this network, as per the direction, remember that, as per the direction, according to the time at t equal to 0, switch is going to be opened. With that, I can say from minus infinity to 0, switch is closed. Here minus infinity to 0, switch is opened. Once the switch is closed, inductor and capacitors are affecting with the source or not? Yes, they are affecting with the source. Inductor and capacitors, they are affecting with the source. Once they are affecting with the source, definitely I can say that, are they charging or discharging? They are charging. Or they get the maximum values where? When the position of the switch is going to be changed. Where they are changing at the position, at what time? At t equal to 0. Are you getting? That's why at t equal to 0, the switch position is going to be changed till t equal to 0. They get that maximum values, either inductor current or capacitor voltage. That's why up to t equal to 0, they are affecting the sources. That's why for t equal to 0, you will have some energy in the inductor and capacitor. Now after t equal to 0, just identify guys how the switching action. Switch is open, inductor and capacitors are not affecting the source. Switch is what? Switch is open. Once the switch is open, inductor and capacitors are no source. If it is no source, then definitely we need to see that whether inductor or capacitors are having initial values or not. Yes, they are having. Once they are having, they are acting as a temporary sources. When they are acting as a temporary sources, are they charging or discharging? They are discharging. Once they are discharging, then definitely I can say that it will come under source free circuit. They are decaying functions. Now under this one, whenever if it is discharging, this will come under source free circuits. Like that, we can decide based on the switching action, source free circuit or with source circuit. Got it this? Is it okay? How we need to decide? According to the given circuit, whether it is source free circuit or with source circuit, source free circuit or with source circuit. Are you getting this concept? This is very important. Once you are able to define source free circuits or with source circuit, definitely we should go for that. The switching actions or switching instants. Here switching instants which we can define, this is very important here. Based on this only we are able to define the maximum values or minimum values of inductor and capacitor. Let me consider that. Is it okay this part? Right, very good. Once you thorough with this, then take this one. This is very important. Here at t equal to 0 minus t equal to 0 plus. These two instants which are happening at t equal to 0, this is at t equal to 0. These two are happening within 0 time. Within 0 time. Based on this only, we are able to define the initial values of inductor and capacitor. First of all, what is t equal to 0 minus, t equal to 0, t equal to 0 plus, t equal to infinity? These you have to know that. And this one is what? The total area, whatever we are considering from t equal to minus infinity to t equal to 0 minus, up to 0 minus. This will consider under t less than 0. And t equal to 0 plus 2, t equal to infinity, this we are considering t greater than 0. Now let me define that. What are the instants? We don't need this response is related with this one. But we have to take that initial values before t equal to 0 if the inductor and capacitors are affecting with the sources. That's why I need to know that what are the instants related. T equal to 0 minus stands for what? T equal to 0 stands for what? T equal to 0 plus, t equal to infinity. Now let me define that those values. See this one. How we have to take it? So very good. This is the very good concept. At t equal to 0 minus you have to take it. That is the first one is t equal to 0 minus. T equal to 0 minus is the instant just before switching action. Just before. Nothing but what? Just before switching action, suppose if the inductor and capacitors are affecting with the source. Till t equal to 0 minus, they are affecting with the sources, they are having this energy, they get maximum energy at t equal to 0 minus, before t equal to 0. That's why that state is nothing but, what state? Steady state. Usually we are considering that from minus infinity to up to t equal to 0 minus, some of the textbooks are referring as steady state. No doubt in this, it is a steady state. But before t also, t less than 0 also, sometimes you may get a sudden change. Under that instant, you may get a charging before t equal to 0 also. Steady state, where you are getting that exactly the steady state position you will get at t equal to 0 minus. This state is nothing but steady state condition for t less than 0, steady state position before t equal to 0, t less than 0, that is before t equal to 0. Now t equal to 0 is what? This is the instant exactly switching action. It may be closed, it is going to be closed or it is going to be opened. Exactly instant, whether it is opened or closed, whether it is going to be opened or going to be closed. Exactly switching action. And at t equal to 0 plus, the instant just after switching action, this is also be considered as a starting point of the transient response. It is the starting point of transient response. This is very important here. Some of the students, you may think that t equal to 0 plus is equal to t greater than 0, but both are not equal. Remember that this value is not equal to t greater than 0. T greater than 0 is not equal to t equal to 0 plus. T greater than 0 means it is the range of the time. 0 to infinity, this is the range. But this is what? At one instant. Like 1 second, 2 seconds, 3 seconds. Is it right? That's why this is the starting point of the transient response. Right? Transient response after t equal to 0. Now the t equal to infinity, this is after t equal to 0, the instant for a long time after switching action, the instant for a long time after switching action. This is also called steady state position after t equal to 0. Steady state position after t equal to 0. Like here, once you see this one, we are getting the two steady state positions. One is before t equal to 0, other is after t equal to 0. Remember that. There is a difference between the two steady state positions. Based on what? Based on switching action. Based on switching action. With this, you need to identify the behavior of inductor, capacitor and resistor. Resistor never react with the frequency or time. That's why you need to be concentrate on only inductor and capacitor behavior at t equal to 0 minus and at t equal to infinity. How it is? These two states are steady states. That's why at t equal to 0 minus, at t equal to infinity, before t equal to 0, after t equal to 0, the positions or the behavior is same for inductor and capacitors. Here what are the difference? Switching actions are different. And at t equal to 0 plus, how the behavior? This is very important for analysis of transient circuits, analysis of the transient response. Now let me consider that the behavior of that one. What is the behavior of that one? See this. Now the behavior of RLC elements at t equal to 0 plus and at t equal to infinity. While coming to that, here the behavior for resistor for t greater than 0, how it will act as? Resistor always act as resistor here. It will not change. Resistor always act as resistor. It will not change. While coming to that resistor at t equal to 0 plus, as it is resistance only. There is no change at t equal to infinite also resistance. Here what is that? I of t, t greater than 0. Remember that. While coming to that inductor, how the inductor act as? Inductor can be considered in two ways. Initially energized inductor, initially not energized inductor. Now initially not energized inductor, after t equal to 0, we are getting that this is I of t. Why I am considering that I of t? Because the flux produced by the inductor is directly proportional to current. Now while coming to that at t equal to 0 plus, at t equal to 0 plus, it will act as open circuit. Suppose there is no charge. No charge means no current. Current 0 means open circuit. You know that. Now after t equal to 0, it is going to be charged. Now till t equal to infinity, it is charged. Now it is acting as a, what it is? It is acting as a short circuit at t equal to infinity. Short circuit means once if it is charging maximum charge you will get it at t equal to infinity. Short circuit offers a maximum current from the excitation. Now while coming to that with source, suppose initially having some energy. How after t equal to 0? You know that after t equal to 0, based on that, I can say that inductor will act as inductance with the parallel current source. This is the total current. I of t is equal to I naught plus 1 by L integral V dt. Both are in parallel. Now at t equal to 0 plus, how you take that? This is acting as open circuit with the parallel current source. Yes or no? Or simply we can take it as a current source. But while coming to that here, under steady state, it is what? It is only short circuit. Short circuit offers maximum current. Some of the textbooks are referring as this one is short circuit with parallel current source. You cannot take like that. Including initial current you will get it. Including initial current. Right? You will not get a current source at t equal to infinite. Only short circuit you have to be considered. While coming to that capacitor, if we take the capacitor, in the capacitor, I can say that here capacitor with initial charge is 0. Now, for the capacitor, voltage is the state variable. That's why you have to be considered like this. Now, at t equal to 0, it is acting as a short circuit. Short circuit means what? No energy. No energy means no charge. Now, at t equal to, once if it is charging, maximum charge you will get it. Maximum voltage will read the open circuit usually. That's why under steady state, capacitor will act as open circuit. Suppose if it is having capacitance with initial value, this is what? Initial voltage. He will provide the polarities. Remember that. He will provide the polarities. Now from this, I can define here, this is the total voltage V of t. Total voltage V of, including initial value. Remember that. According to the, what it is? According to the formula. According to the formula here, including initial value. Now this will be at t equal to 0, it is short circuit with voltage source, or simply we can say that it is acting as voltage source. It is acting as voltage source. While coming to that at t equal to infinity, under steady state, it is having a open circuit which reaches the maximum effective voltage with the all the excitation. This is the table which you need to remember. This is compulsory, you have to be remember while taking the questions under transient circuit analysis. You should have this the behavior at t equal to 0 plus at t equal to infinity. See this, t greater than 0, t equal to 0 plus, both are not equal. Here inductor act as inductor, here inductor act as open circuit. Remember that this is the difference, both are not equal. Right, some of the students you may have some doubt regarding the t greater than 0, t equal to 0 plus, both are not equal. This is the range, this is instant, one instant, right? Now, I can summarize like this here. This is the behavior of this one. Just now whatever we have taken, I can summarize. Now at t equal to 0 plus with initial value, it is acting as a current source, and capacitor with initial value voltage source. At t equal to infinity, open circuit, open circuit. Now, let me consider some of the important concept under first order source free circuits, right? Now, RL source free circuit, is there any physical source, nothing but independent source is existing? No, it is not existing independent source. Once if it is not existing, then definitely this will come under what? Source free circuit. For source free circuit, how the inductor act as temporary source? What is the current response? Here we are getting that. Why we are taking the current response for an inductor? Because state variables for inductor is what? Current. For capacitor is voltage. Now let me take that here. The solution for this one, how you have to be considered. Some of the mathematical things required here. Now by KVL, I can take it. See this? By KVL for this one, I will get it. By KVL. You will get it this one. How you consider that? By KVL, this is VL and this is VR. VL plus VR is equal to 0. Now L into DIL by dt plus IL of t into R is equal to 0. Now finally, this is the first order differential equation. You are getting that R by L into IL is equal to 0. This is the first order differential equation. I would like to recall that first order differential equation in mathematics. Dy by dx plus py is equal to q. The solution, if you want to get it, we need to go for integrating factor, integral e power p dt or p dx. We need to be considered. Once you will get that, the solution for this one is what? Y into integrating factor is equal to integral of q into integrating factor into dt plus c. To obtain the c value, we need to go for the initial values. That's why for this one, the integrating factor, tell me the integrating factor, guys. Integrating factor for this one, we can get it here e power integral r by L into dt. Now from that, I can get it e power r by L into t, you will get it. Now what is the solution for this one? You know that the solution I can take it y. Y is what? IL of t into integrating factor e power r by L into t integration of q is what here? Q is what? Q is 0. Because this is source free circuit. That's why e power r by L into t into dt plus c. Now 0 into something is 0. Everything is 0 here. 0 into something, that part. Then the rest of that one is what? IL of t I can define as what it is? C into e power minus r by L into t amperes for t greater than or equal to 0. Now here the C is the unknown value. To obtain the C value, definitely we should go for initial conditions. What are the initial conditions? Now at t equal to 0 plus, what it is? Inductor act as, is it having initial value or not? Yes, that's why it is acting as what? A current source or open circuit parallel current source. And while coming to that resistor always act as a resistance. Now let me take that how the circuit we are having. The circuit based on the given RL source free circuit will come like this. Is it right? According to the direction is provided R. Now as per that here this is VL and this is VR we have taken. Is it right? Now tell me that what is the initial current or I of 0 plus or I of 0 plus value how much? Now according to that I can take it I of 0 plus value is equal to I of 0 plus value is equal to, see this one I of 0 plus value I can take it as here I naught. From this I can define finally I of 0 plus is equal to C into e power 0. From this C is equal to what? I naught we are getting. Finally I can take it IL of t is equal to I naught into e to the power minus t by tau amperes, where tau is equal to L by R seconds. L by R seconds. You can take this one here. This is the final expression for source free circuits. Final expression for the source free circuit. Is it right? This is the expression you have to be remember. Now once you take that, the response how it is. Response, if you are considering that, see this one how the response will be. The response will be like this. Now at t equal to 0, what we are getting that the current response is equal to I naught at t equal to 0. Now at t equal to infinity, what it is? It is 0 because e power minus infinity. Now how the response? Response will be decaying function. Is it right? Now this function is, this is the function I can take it here. This is the current function. Whenever it is discharging, inductor is discharging. Right. Now here guys you have to be remember two things. Number one is at one time constant how much that value, and at how many times of the constant time constant it is going to be reach its steady state value. Now at one time constant, suppose if you are considering this is at one time constant, we are getting at one time constant here. This is 0.368 times of I naught. That's why guys remember these values are very important. E power minus 1 value 0.368 and 1 minus e power minus 1 value 0.632. 0.632. These values you should be remember. These values you should be remember. These are very important. Now while coming to this one, at one time constant 36.8% of its initial value of the current decaying. While coming to that, here the steady state value nearly equal to steady state value you will get it at t equal to 5 tau. Ideally, practically we can take it 5 tau. Ideally you can take it infinity, but at this instant it is nearly equal to 0.0068 times of I naught. With this I can say the response from 0 to up to 5 tau, whatever the response we are getting, that response will be considered as a transient response. After that the response is not changed with respect to time. That response is nothing but the steady state response. That response is nothing but what? Steady state response. Remember this. This is the way how we are getting the transient as well as steady state response. Right? And one more thing here you have to identify. Sir, you have given that inductor is discharging now. It is acting as a temporary source now. But you have considered that in the circuit, whatever we have taken that, you have considered in the circuit, see this, the current is entering at the positive terminal. But actually, its inductor is acting as a temporary source. Whenever it is acting as a temporary source, it has to be here delivered. Whenever delivered, it should be definitely negative to positive. Na? Then how you justify this one? If you want to justify that, VL value we need to be estimated. Now according to that VL value, see this one, if you want to define that VL value from the, if you want to define that VL value from IL of t, tell me that what we are getting? VL of t is equal to L into dIL of t by dt. Is it right? Now from this I can take it I naught into e power minus r by L into t. E power at integration is differentiation is what? E power at into a. LL will be cancelled minus I naught into r into e power minus r by L into t holds. Whatever the voltage expression we got, based on this voltage expression, I can say the negative sign here which we obtained, this is what? Negative voltage means what? Negative current is reverse direction. Negative voltage means what? Reverse polarities. That's why as per the IL of t, the voltage polarities should be considered reverse. That reflects current should enter at the negative terminal of inductor. Nothing but inductor is discharging. It is acting as a temporary source. This is the way how I can justify inductor is a temporary source. It is delivering through the resistor again. It is discharging through the resistor. This is about the source free circuit. Right. Now, in this you have to remember 2 points. First one is the current response of IL of t. Second point is inductor voltage terminal should be reverse. Inductor is discharging under source free circuits. Right. Now, let me consider one simple example in this. Guys, if you take one simple example, then definitely you will get a clarity. Now, see this one. The switch in the circuit shown in figure was closed for a long time and it is opened at t equal to 0. Determine IL of 0 plus IL of t for t greater than 0 and VL of 0 plus values. See this one. This is the circuit given here. Guys, for these type of circuits under transients, remember 3 things we need to be verify. For transient circuit analysis. What are the 3 things you need to be verify? See this one. The 3 things you need to be verify are, the first one is switching action is provided or not. Switching action is provided or not. For what? For sudden change. First you have to identify this one. This is the first one. Second one, energy storage element is present or not. Energy storage element is present or not. Without these two, you cannot take the transient analysis. You will not get the transient response. You will get it only steady state if these two are not happening or any one is not happening. Right? Now the third thing is, once you confirm these two, if you are going to be transient circuit analysis, one more thing you need to be check or you need to be identify, that is what? Initial values of energy storage element. Initial values of energy storage elements, which are what? Inductor and capacitor, given or not? Suppose if it is given, we need not go for before t equal to 0. Why? Because inductor and capacitors are also called history elements. If some history is existing, we need to be considered after t equal to 0. If it is not existing, you need not to be considered. That's why for that we need to be check it. If it is given, we have to be considered. If it is not given, we need to be check it by taking the switching action before t equal to 0. Based on that, I can define the value of initial inductor current, capacitor voltage. These 3 things should be happen. Now let me consider that how we need to be consider these 3 things. Now I will provide with one diagram. Guys, remember value we have to be estimate IL of t. See this one. Now see this, how the t less than 0 condition. Switching action is there, energy storage element is there, initial value is not given. That's why, is it given initial value in the data or in the circuit? Not given. That's why we should consider that for t less than 0, how the switching action. See that for the t less than 0 switching action, it is closed. Yes. For t less than 0, switch is closed. Switch is closed. Now is the inductor is affecting with the source? Yes, inductor is affecting with what? 2 ampere source. Are you getting that? Inductor is affecting with the 2 ampere source or not? Yes, it is affecting with the 2 ampere source. Then definitely we should be consider whenever if it is affecting with the 2 ampere source, if it is not affecting, then directly you can take it initial current value is equal to 0. If it is affecting, then definitely we should be consider the initial value where at t equal to 0 minus na. This state is what? Steady state na. Under steady state, how the inductor act as, or how you find out the initial value by taking the position of the circuit at t equal to 0 minus by replacing inductor under steady state as a short circuit path current. Short circuit path current. That current is what current? IL of 0 minus. Should be considered as what current? At t equal to 0 plus. Why we are considering this one? Since within 0 time there is no change in the current of inductor. Since in an inductor current does not change instantaneously. That's why here IL of 0 minus I can take it IL of 0 plus, which is same as I naught. That I naught is nothing but what? Initial current of an inductor. Initial current of an inductor. Are you going to get it according to the circuit from the circuit? Yes. See this one. As per that here before t equal to 0, see this one, before t equal to 0, switch position is what? Switch position, I can take it, switch position is closed. Once the switch is closed, inductor how you take it? At t equal to 0 minus short circuit na. Once you take that switch is closed, current source, resistance, inductor, 10 ohms resistor, all are in parallel na. By taking the inductor as a short circuit, you are aware of that across short circuit any passive element can be neglected. Why? Because there is no current is passing through that. Since the current which is coming from the source is always choose low resistive path. If all are in parallel, the current will choose any short circuit is provided, entire current is passing through the short circuit path. This is the way how the current will flow, where at t equal to 0 minus when the inductor is short circuit, no current in 20 ohms and 10 ohms resistor. Is it right? That's why that current is what current? It is the 2 amperes. That is IL of 0 minus. That IL of 0 minus can be considered as what it is? Can be considered as initial current of an inductor. What it is? We are getting here 2 amperes is I naught. Are you getting? This is the way how you need to extract the initial value of either inductor while taking the capacitor as open circuit. Is it right? Now while coming to that I naught value is 2 amperes. Now let us take that our required value. One of the required value we got it now. As per this what value you have to estimate here? This value IL of 0 plus we got it. And next value is what? For t greater than 0. Then definitely we need to go for t greater than 0. For t greater than 0, switch position is what? Open. Once you identify that for t greater than 0, switch is opened. How the network is the inductor is affecting with the source? No, it is not affecting. Some of the students I am getting that from the students here, they are asking that, sir, after t equal to 0, current source is also connected with the inductor circuit now. Physically it is connected here, but electrically it is not connected. Electrically it is not connected. How it is here? See this one. After t equal to 0, I can draw the network. This is what? For t greater than 0, switch is opened. Once the switch is opened, I can say that the network will be like this. Students are confusing for these type of examples here. You should be clear with this. Physically connected. This is the circuit. No doubt in that. Here 2 amperes is there. Here 20 ohms is there. Here 10 ohms is there. Here inductor 2 henries is there. And IL of T is there. And I naught is also there 2 amperes. Sir, why this 2 amperes is not affecting with this? Physical connection is there, but electrically there is no connection. How you justify this statement? Here current is passing through these 2 amperes. If 2 amperes is dividing, is there any return path for this one? No. That's why entire current, how much 2 amperes is entering, same current is should leave. Then only KCL is satisfying. Like that, here also, if IL of T is entering, here IL of T is leaving. That's why these two are physically connected, but electrically they are not connected. Electrically they are not connected. With this, I can say here these two are what? These two are, I can say that these two are different. These two are different. I can say that these two are different circuits. These two are different circuits. These two are not connected electrically. They are connected physically. That's why this will come under source free circuit. This will come under source free circuit. That's why after t equal to 0, remember that. Have you got the concept how you have taken? After t equal to 0, switch is open. Inductor is not having source, no source, but it is having initial value. That's why I will take it that as a RL source free circuit. Whenever if it is RL source free circuit, is it charging or discharging? Then definitely it is discharging. Then you are having the formula for discharging current expression. What is the discharging current expression? Tell me that. IL of T is equal to I naught into direct formula you are having e power minus T by tau. Where tau is what? Tau is equal to L by R. Here all are having some doubt. Sir, why we are not considering for R value this 20 ohms? We are finding the response for the source free circuit. Only you have to be consider this one. Should not be considered the 20 ohms resistor. It should not be considered the 20 ohms resistor. That's why here we should be consider here 2 and 10. Is it right? According to the 2 and 10, we are getting that 1 by 5 second. Are you getting? Is it clear? Now as per that 10 ohms resistance and 2 Henry inductor, this is only you have to be considered. You should not be considered this 20 ohms resistor while finding the time constant after t equal to 0. With this, I can get the value of IL of t is I naught value how much? 2 into e to the power minus 5t amperes. From this one you have to get it here. Don't go for the calculation. Don't go for anything. From this diagram you have to be get these two values. You have to be get it, these two values, right? Now while coming to this here, what we have taken, while coming to the question, what is the question? For t greater than 0 and also V of 0 plus, VL of 0 plus, VL of 0 plus, definitely you will get negative because L into DIL of 0 plus by dt, L into DIL of 0 plus by dt. Or sometimes you may ask that the question related with V of 0 plus here. Then under that instant I naught is existing na, at t equal to 0 plus. See this one. At t equal to 0 plus, how you take the circuit? At t equal to 0 plus, see this one. Guys, are you getting? At t equal to 0 plus, this is open circuit. Now I can take that at t equal to 0 plus circuit also. At t equal to 0 plus. See this, at t equal to 0 plus. Inductor is what? Current source. Open circuit with current source. Resistor is as it is. That's why here we are getting this is the circuit at t equal to 0 plus. How the current direction of initial current 2 amperes I naught value based on this, based on the previous one. right? Now, according to this, how much current is coming from this? The current is coming 2 amperes here, 2 amperes here. That's why, suppose V of 0 plus is here. It is not VL of 0 plus here, V of 0 plus only. Now, V of 0 plus is equal to, VL of 0 plus is different. V of 0 plus is what? I naught into R. As per the polarities, guys, these polarities he was given here, positive to negative. That's why 2 into 10, which is equal to what? 20 volts positive across resistor. This is not across inductor. Definitely across inductor, you will get negative. That also you can see that VL of 0 plus, suppose if you want to get it that. VL of 0 plus, is it okay? Now VL of 0 plus, if you want to get it that, first VL of t is what? L into d I of t by dt. D is what? 2 into e power minus 5t into minus 5. Yes or no? How much you are getting that? Minus 20, na? E power minus 5t. VL of 0 plus or VL of t. If you take at t equal to 0 plus, what we are getting that? VL of 0 plus value is equal to minus 20 volts. Remember this. Should be, you should get it negative value. You should get it negative value. This is positive value according to this. These two things you need to be identified. These two things you need to be identified. This is about RL source free circuit. But guys, here whenever given this one, you should take this diagram only. This is the diagram you should be remember. Is it correct? Is it okay? Is it okay? Any response? Right. This is about the RL source free circuits. Now let me consider that the next example. This example you will see this one. Under RC source free circuit, I am writing directly. I am writing directly Vc of t is equal to V naught into e to the power minus t by tau volts, you will get it. E to the power minus t by tau volts, you will get it. Same procedure we have to take it that. And negative Ic of t, you will get it as a negative. Ic of t is equal to C into d Vc of t by dt. This value you will get as a negative. This value you will get as a negative. Now while coming to this one here, at t equal to 0 plus at t equal to infinity. Usually the networks which we are considering at t equal to 0 plus at t equal to infinity, how the responses are there. And before going to this, you need to be know that the universal formula for source free circuits with source circuits. This is very important here. Source free circuits with source circuit, the universal formula is here for an inductor RL first order circuit, IL of t is equal to IL of infinity plus IL of 0 minus IL of infinity into e to the power minus t by tau amperes for t greater than or equal to 0. Like that. This is valid for both. Here infinity means final value. This is initial value. And tau is the time constant. For RC, we are having Vc of t is equal to Vc of infinity plus Vc of 0 minus Vc of infinity into e to the power minus t by tau volts for t greater than or equal to 0. For t greater than or equal to 0. This is related with this final value and initial value. Right? This is for first order with source or source free circuit. Now while coming to this one, at t equal to 0 plus and at t equal to infinity. And at t equal to 0 plus at t equal to infinity, circuit nature is what? Resistive nature. Why? Because at t equal to 0 plus at t equal to infinity, at t equal to 0 plus how the inductor acts as? Inductor is open circuit with current source. Capacitor is what? Short circuit with voltage source if it is existing. Like that, I can take it at t equal to infinity is what? Inductor is short circuit. Always open circuit. That's why above the two instants, the inductor and capacitors will lose their significance since they are acting as either open circuit or short circuits. That's why the total circuit nature is what? Resistive. We can easily find out the what values? The responses are finite values because there is no inductor, there is no capacitor. At t equal to 0 plus and at t equal to infinity. At t equal to 0 plus and at t equal to infinity. Is it right? Now let me take that here. The simple example under this one. See this here at t equal to 0 plus and at t equal to infinity. Here inductor open circuit, capacitor short circuit. Here inductor short circuit, capacitor is open circuit. But guys, in between that, how the inductor act as and capacitor act as, how the inductor and how the capacitor act as, in between that, inductor act as inductor only. Remember that, capacitor act as a capacitor only. If it is initial value, how to be considered? In between that, this is what usually this will be considered for t greater than 0. Only at t equal to 0 plus t equal to infinity, circuit nature is resistive nature. Is it right? Now, based on this, we will take the one simple example under this one. See this. Find the response I of t at t equal to 0 plus and at t equal to infinity. How you have to take it this? Guys, tell me this. Now at t equal to 0 plus at t equal to infinity. At t equal to 0 plus at t equal to infinity, if you want to get the values, here 3 points or 3 verifications we have to do it. First one is what? Switching action provided. Second one is what? Energy storage element. Both are there. This is under second order. And third one is what? Initial values are given? No, not given. If it is initial values are not given, will you take directly those values are 0? No, we need to be check it whether 0 or finite values are existing by using what? By taking the switching action before t equal to 0. Since these initial values are also called history values. History will come before t equal to 0. That's why according to the switching action before t equal to 0, what is the switching action before t equal to 0? Open. Is the inductor and capacitors are affecting with the 100 volt source? No, they are not affecting. If they are not affecting, then initial values are what? 0. Once the initial values are 0, once you confirm that, this is the confirmation you have to be done while you are considering after t equal to 0. At t equal to 0, before t equal to 0, switch position is what? Open. Inductor and capacitors are not affecting. That's why initial values are 0. This is the confirmation. Now take at t equal to 0 plus. At t equal to 0 plus, switch position is what? Closed. Now how the inductor? Open circuit. How the capacitor? Short circuit. Based on the table. Now can you get it that I of 0 plus? Yes. 100 by 10 plus 50. 100 by 60. 10 by 6. Nothing but what? 5 by 3. Now with this directly you are able to take that here. I can consider directly I of 0 plus is equal to what it is? 100 by 10 plus 50, which is equal to 5 by 3 amperes. This is what? I of 0 plus. Battery current, sometimes he may give that as battery current. Yes or no? Now I of infinity. I of infinity directly you can take it now. At t equal to 0 plus, inductor is what? Open circuit. Capacitor is what? Short circuit. Guys, this everything you need to be assume or you have to be imagine that. Once you imagine that, then definitely you can take it this. Now at t equal to infinity, this is short circuit, this is open circuit. I of t is existing or not? Yes. Previously at t equal to 0 plus the battery current is passing through the capacitor which is provided short circuit. Now at t equal to infinity which is passing through the short circuit provided by the inductor. That's why I can say that I of infinity is equal to 100 by 10. This will not coming into the picture. Then you will get 10 amperes. This is what? Steady state current. This is what? Steady state current. Is it right? Now, by taking these two, then definitely I will get it. The at t equal to 0 plus at t equal to infinity values are what? Finite values. This is about the second order system which we need to be consider. Is it right? Now, the next one is very important concept here. This is what here Laplace transformation. When we need to go for Laplace transformation, usually after t equal to 0 condition, we need to go for Laplace transformation. Why we are going for Laplace transformation? What is the significance of the Laplace transformation? Once you take that network from t domain to s domain, definitely you will get that all the passive elements are having unique dimensions. All the passive elements are having unique dimensions, right? That's why a resistor you will have under this one as a R ohms. While coming to that inductor, you will have what? S into L, because ZL is equal to J omega L, S into L ohms you are getting. While coming to that inductor, see this one, inductor is with initial value, it is a constant now. You know that constant Laplace is what? I naught by S. Like that for capacitor, 1 by Cs. What are the units? Ohms. All are having unique dimensions. Capacitor and inductors all are having unique dimensions. Like that here, capacitor also initial value V naught by S. This is what? 1 by Cs. These are also ohms. This is the way how we can convert from t domain to s domain. Here Henrys is there, here farads are there. We cannot take directly, but here ohms, here also ohms, here also ohms. We can take it ohms law directly, V is equal to I into Z. That is the advantage by converting from S domain to T domain. Within less steps we are going to get the solution. That's why within the stipulated time we are able to get the solution. That is the advantage of the Laplace, right? And one more thing here, this is very important here, identification of, this is very important, identification of impulse, identification of impulse. When the network at t equal to 0 plus there is a violation of KCL and KVL, then the excitation or response is usually impulse. First of all, what is the impulse? You know that this is the impulse. You are having that, this is the impulse. And how you identify in the network impulse, excitation or response. See this one. This is very important for you. Once if you take that, the network at t equal to 0 plus, if it is violation of KVL or KCL, then definitely you may think that you need to identify there is a impulse, excitation or response. How the impulse excitation, how the impulse response, where the impulse excitation, where the impulse response you are getting. For that you have to be know these two things. Number one is, in an inductor, current nothing but energy, since psi is directly proportional to I, cannot change instantaneously for all practical sources. While coming to that, but current can change instantaneously for an impulse excitation. Why impulse excitation? Because see this one. Here within 0 minus to 0 plus it is changing. Integration of 0 minus to 0 plus, integration of impulse is what? This we are getting as what? 1 Laplace of this one. We are able to define that from 0 minus to 0 plus. That's why for an impulse excitation, definitely current can change instantaneously. Now while coming to that, for capacitor, similarly across capacitor, voltage cannot change instantaneously for all practical sources. but the voltage can change instantaneously for an impulse excitation. An impulse excitation. Remember this one. Are you getting? Is it clear? Now, and remember this one. Whenever if there is a violation of KCL, then impulse voltage will occur. Similarly, there is a violation of KVL, then impulse current will occur. These two things we know that. KCL, violation of KCL, impulse voltage. Violation of KVL, impulse current you will get it. When there is a violation of KCL or KVL, then definitely the analysis we should be considered with the Laplace. Analysis will be considered with the Laplace. Why? Because impulse Laplace can be defined. Laplace of impulse is equal to unit. That is what? 1. That's why if you take that under Laplace for any circuit, definitely you will get our required value within the given stipulated time. Now let us take that one simple example under this one. Are you getting? These 2 points are very important here. Whenever impulse response, impulse excitation. When impulse response, when impulse excitation for an inductor and capacitor. Now let me take this one. This is the previous examination, gate examination question. Right. In the following network, C1 and C2 are ideal capacitors and C1 has been charged 12 volts before the ideal switch S is closed at t equal to 0. The current I of t for all t's, he wants to take after t equal to 0, what is the current response? Usually for capacitors, voltage responses, but here guys, if you see that this is having ideal, what it is? Ideal capacitors. Both are ideal capacitor. One is charged with some voltage, nothing but what? 12 volts. This value, V0 value is equal to what? 0. Now let us take that after t equal to 0. After t equal to 0, how it is? After t equal to 0, the network can be like this. For t greater than 0, see this one? If you want to get it that here 12 volts and capacitor C1, capacitor C2, this is I of t. If you want to get it that I of t, then definitely we need to go for Laplace. Why? Because see this one. Normal analysis is not possible. If you take that I of t, it will take so much time, and first you identify that at t equal to 0 plus, at t equal to 0 plus. To define impulse response is going to be happening or going to be get it under this one. That's why we need to go for at t equal to 0 plus. This is the circuit can be defined like this. This is the short circuit, this is the short circuit. Is it accepting that KVL? No, it is not accepting the KVL. I of 0 plus. It is violation of KVL. 12 plus 0 is not equal to 0. It is what? Violation of KVL. Then what response you will get it? Violation of KVL. See this one. Violation of KVL. What response you are getting that? Violation of KVL. Current, impulse current you will get it. Violation of KVL, impulse current you will get it. That's why we should be consider this example. What response? Impulse response you will get it. Directly you can take it by using that. Directly we can take it by using the at t equal to 0 minus condition. At t equal to 0 plus condition. And we can also get it by using the Laplace also. Now, let me consider that by using the Laplace for t greater than or equal to 0. Now, for t greater than 0, switch is closed. Now, under t domain, from the t domain to S domain, how you consider this? From t domain to S domain, the network is going to be 12 by S, 1 by C1S, 1 by C2S, and I of S. Tell me this one. What I can take it? 12 by S is equal to I of S into 1 by C1S plus 1 by C2S. What we are getting with this? What is that? Here C1 plus C2 by C1 C2S. Is it right? Is it clear? Now from this I can say SS will be cancelled. You are getting that I of S is equal to 12 C1 C2 by C1 plus C2. This is what? A constant. For a constant, inverse Laplace is nothing but by taking by ILT, inverse Laplace transformation, I of t is, it is what? Impulse. Impulse. This is the way how we can take it. This is the way how we can take it for impulse excitation or impulse response. Identification of impulse. Identification of impulse. Is it right? Now you can also identify this one. This is also, we need to estimate what? At t equal to 0 plus. At t equal to 0 plus. Now see this one at t equal to 0 plus. This is the same example. I can take it at t equal to 0 plus. Suppose if we consider this one. Inductor is what? Inductor will be like this, na? Getting? At t equal to 0 plus. This is 2 amperes, this is 1 ampere. Now open circuit, open circuit. According to this, I can say that as per that by KCL at x, by KCL at x point. Tell me that guys, here 2 is incoming, 1 is incoming. Is it 3 is not equal to 0 na? That's why it is what? Violation of KVL or KCL? It is violation of KCL. Violation of KCL, what you will get it? Excitation is what? Excitation is impulse excitation, you will get it for this one. Analysis, if you want to do that, we should go for what? Laplace. We should go for Laplace. Now, by considering this one here, I will take it by using the Laplace. By taking the Laplace by LTA, Laplace transform analysis, you will get it. See this one? 1 by S, 2 by S, 2S, 2S, I of S. Now, what the next we have to do it? If you want to take the analysis, then definitely we need to go for what? For this one, source transformation technique. By doing the source transformation technique, you will get it. This is the source transformation technique. By doing that, from the voltage source to current source, you can convert from current source to voltage source. Current always from negative to positive. This is what we are getting, that 4 volts, same impedance, 2 volts, same impedance according to the direction. Now resultant current I of S value, how much you are getting that? I of S value is equal to 4, both are opposing na? 4 minus 2 by 2S plus 2S, 2 by 4S, 1 by 2S amperes. And while coming to this one, then definitely I can take it by ILT, by inverse Laplace transformation. I of t is equal to 1 by 2 amperes. It is valid for t greater than or equal to 0. From 0 to up to infinity, current we are getting a constant current. That's why according to the given, as per the given, see this one. As per the given, what it is? 1 by 2, no? Answer is what? B is the correct answer. First, guys, see this one. First, according to that, t equal to 0 plus, it is a violation of KCL. That's why definitely we should go for the Laplace for t greater than 0. Now, by using the Laplace, we are getting that current for t greater than 0, it is a constant. Since the excitation is the impulse excitation. Is that right? impulse excitation. Now while coming to that, the next one, see this. This is very important under special case. In the following network, all the elements are used or ideal. For t less than 0, S1 remains closed and S2 is opened. T equal to 0, S1 is opened, S2 is closed. If the voltage across VC2 across capacitor 2 is 0, then voltage across the capacitor combination. This is very important example here. This is very important example. Once you take that here 3 volts, before t equal to 0, the same rule. What is the rules? First one, switching action is there? Yes. Energy storage elements are there? Yes. Initial value is given? Not given. That's why we need to go for before t equal to 0. Before t equal to 0, according to this is what? S1 is closed, S2 is opened, 2 farad is affecting with 3 volts, 1 farad is not affecting with this. That's why how much the 2 farad voltage? 3 volts. 1 farad is not having. Now after t equal to 0, how the capacitor voltage, capacitor combination voltage we are having. Capacitor combination voltage we are having. For that, here I can say that after t equal to 0, you know that for t less than 0, S1 is closed, S2 is open. Remember this. Now with this I can take it, the network C1 is affecting with 3 volts, C2 is no source. That's why Vc1 of 0, here we are getting 3 volts. Now define at t equal to 0 plus. At t equal to 0 plus, C1 is short circuit with 3 volts. C2 is only short circuit with 0 volts. Now define that. This one I can take it here. At t equal to 0, see this one, short circuit with 3 volts, and this is only short circuit, and this one is what? Short circuit. This one is what? Short circuit. Then definitely it is what? It is violation of what? KVL. 3 plus 0 is equal to 0. With this it is not equal to 0. With this, what I can say? It is violation of KVL. Then how we need to consider that whenever if it is violation of KVL, see this one, then definitely we need to go for Laplace transformation by LTA. I can take it. Are you getting this? By LTA, see this, capacitor, voltage source, capacitor, this value how much? 3 by S. How much the capacitance value? 2 farad, 1 farad. 1 by 2S, 1 by S. Capacitor combination voltage here. This is our required value. V combination. If you want to get V combination, what I can take it? Directly voltage across 1 by S, na? If you want to get that voltage across 1 by S, then definitely I can take it I of S. Now tell me that I of S value, 3 by S is equal to 1 by 2S plus 1 by S into I of S. Now what we are getting with this? 3 by 2S, 3 by S is equal to I of S. Are you getting? Now from this SS will be cancelled. What we are getting that I of S? I of S is equal to 2. Now from this I can take it V combination of S is equal to I of S into 1 by S. Is it right? Now what we are getting that final value? Final value V combination is equal to 2 by S. Now by inverse Laplace transformation, what we are getting? V combination is equal to, how much you are getting that? 2 volts. This is the way how you have to take it. This is the way how you have to take it. The combination voltage. You may get a doubt, sir, why we have taken only across 1 farad? Why can't you take here? Both are same here. While you are considering this one, how much voltage here we are having? Same voltage you will get it. At t equal to 0 plus or after t equal to 0, the total voltage will be divided equally across capacitors when the impulse or excitation or response is existing. If impulse response is existing, then definitely after t equal to 0 or at t equal to 0 or after t equal to 0, the capacitor combination voltage should be equal. For this one, I can also give here one simple example. See this one. Suppose two containers are there. This is what? This is C1 and this is C2. With both are initial values. This is the switch, I can take it. Once you open the switch, then definitely here what we are getting that VC1 of 0 and VC2 of 0, this one. But once you open that, nothing but what? This is for t greater than 0. When the switch is opened here, V combination is equal to V combination across VC1 is equal to VC2. Both are equal, you will get it. Equal level, you will get it. Even though here different level is there. After t equal to 0, V combination. This is called charge distribution. Charge distribution. Q equal to Q1 plus Q2. With this one also, C equivalent into Q is equal to V is equal to V combination. C into V combination is equal to C1 V1 plus C2 V2. This is C equivalent. Finally, you can get it. V combination is equal to, from this one also you can get it here formula. This is the charge distribution for the capacitors. Both are connected in parallel. Na? Using this formula, you can also get it. Using this formula, you can also get it. V combination is equal to C1, how much? 2 into V1, 3 plus what we are getting that C2, 1 into 0 by what we are getting that 2 plus 1, nothing but 6 by 3, which is equal to 2 volts. Same you got it. Are you getting? Is it clear? This is the way how we can take it the special cases. This is the way how we can take it the special cases. Is it right? And previous one, for inductors also, for this one also, flux charge conservation. This is the charge conservation. Charge conservation this is, and previous one we can consider that flux conservation. Nothing but what? Psi is equal to psi 1 plus psi 2. Nothing but L equivalent into I is equal to L1 I1 plus L2 I2. Now plus or minus, both are same direction, then you can take it this. Plus or minus L2 I2 by L1 plus L2. This is the way you can get it. This is the way you can get it. Here it is what? 2 into, how much this is? 2 minus 2 into 1 by, what it is? 2 plus 2. How much? 2 by 4. 1 by 2 amperes, which is valid for t greater than 0, after t equal to 0. This is the flux conservation. Remember this, guys. And here, charge conservation. Right? Now, what is the time now? 8:30. 1.5 hours you have completed. Actually, we are having only 1 hour. Anyway, I think you are having some of the concepts, good concepts, special cases. This is very important. This case, right? Now let me consider that one or two examples, we will see that. Then with that we will wind up. Okay? Please, special cases, special functions are there. Then how you have to be considered. Practice question. Come on guys, now time for you. Tell me this one. Consider an LR circuit in which a current I is equal to 5 into e power minus 2t amperes is flowing the voltage across RL circuit. V of t, how to estimate here? How you estimate V of t? Tell me, any one of you? Here, whenever if I of t is given, this type of function, definitely we should go for Laplace. Then how you replace this one? As S ohms. Now V of t is what? I of t into what it is? R plus L into di by dt. Now instead of this, directly we can take it Laplace V of S is equal to, by using the Laplace, this is the solution, I can take it by LTA, Laplace transform analysis, I of S into what I can take it? 4 plus S na? Now can you take that I of S? I of S is what? 5 by S plus 2 into 4 plus S. Yes or no? V of t is equal to, he wants that voltage across this one. How you take that voltage across this one? RL circuit. Now can you consider this one? V of S is equal to 5 into, what we can take it? 1 plus 1 by S plus 2. Can I consider like this? Under Laplace, 5 by S plus 2. Here S plus 4 is given. R is 4 amperes. Now directly you can get it this one. Inverse Laplace. By taking the inverse Laplace, 5 into e power. What we are getting this? Is it having any initial value? No, I of t is given. By using the Laplace, voltage across RL circuit. Using this Laplace, you can get it. Is it right? Consider LR circuit, which current is having 5 into e power minus 2t. And here 4 given. Now tell me that, how we can take it? S plus 4 by S plus 2. Is it okay? Voltage. I think this value is not proper. Let us take the right. Right, these are the questions I am providing to you, and this was given in the previous examinations. I think the previous one is having data is not correct. Anyway, some impulse response you may get it there. According to the options, it is not suitable. That's why we can take this one, input applied for t less than t naught. Instead of 0, this is t less than t naught, you can take it. This is equal to t naught, t greater than t naught. Consider the following data, input applied for t less than t naught, input applied for t greater than or equal to t naught, state of the network t equal to t naught, state of the network t less than. Here, guys, This example is very good example. State of the network, nothing but what? Initial values when we are getting, till now we have taken the initial values for t less than 0, na? Yes or no? For t less than 0 we are getting. That's why initial value state of the network will be is equal to t less than t naught. And input is applied, it is not correct. Input we are applying for t greater than or equal to t naught. State of the network is not at t equal to 0. T equal to 0 minus, which will come under t less than t naught. That's why 1 and 2 and 4 are correct. Now which is the correct option? D is the correct option. Is it right? Right. This is also a good one. Vs plus 2 times of Vs. For Vs, the response of an initially relaxed linear circuit to a signal Vs is e power minus 2t. This is the ESC, Engineering Service Examination question. If the signal changed with this, then what is the response? For this Vs, the response is e power minus 2t into u of t. If the signal is changed, Vs plus 2 times of dVs by dt, then directly you can take it. Na? Vs is what? E power minus 2t into u of t. Now 2 into differentiation of this is what? This is just like u by uv format now. This is uv format. What is the differentiation of u into v? Differentiation of u is what? E power minus 2t into minus 2 into u of t plus, what is the differentiation of this one? U of t differentiation is what? Delta. Impulse we are getting that. Impulse we are getting. Is it right? Now while coming to this one here, e power minus 2t into u of t minus 4 into e power minus 2t plus 2 into e power minus 2t into delta of t. And guys, here we are getting 3 into minus 3 into e power minus 2t. Look here. And remember here, delta of t is existing what? Only at t equal to 0. Other than t equal to 0, delta of value, delta t value, how much? It is 0. That's why only we are getting at this t equal to 0. At t equal to 0, this value how much? It is 1, e power 0. Then finally, what value you are getting that? Minus 3 into e power minus 2t. See this? Into u of t. Here also u of t is there. Now, plus 2 into, what it is? Delta of t. This is the response here we are getting. This is the response here we are getting that. Then which is the correct option? The correct option is B is the correct option. This is the way how you have to do that, how we need to be considered. This is the way how we need to be considered. You should know that at t equal to 0, e power 0 value is 1 because it is existing. Other than t equal to 0, it is 0. Then 0 into something is 0. That's why 2 into delta of t you have to be considered. 2 into delta of t you have to be considered. Is it right? Is it clear? All of you? Is it okay? Right, very good. Right, this is a very good example here. You see this one, do this one. Same way you can get it, right? The same way you can get it. Switch is closed, switching action is there, and energy storage element is there. Initial value is given for this? No, not given. That's why we need to go for before t equal to 0. Before t equal to 0, switch position is what? Open. Inductor is affecting with the 10 volts, 10 ampere source. Then make it this as a short circuit. How much current is passing through that? Initial current of inductor is what? Can I take this one? Initial current of inductor is equal to how much you are getting? 5 amperes. Na? Now after t equal to 0, switch is closed. This is the gate example. Now this current is required where at t equal to 0.5 seconds. Now at t equal to 0 plus this switch is closed. Are you getting? Before t equal to 0, see this one. Before t, 3 conditions. switching action, energy storage element, initial value is not given. That's why before t equal to 0, switch is opened. That's why inductor is affecting with this. Make it, this is a short circuit. Equal current is dividing. I is 5 amperes. Now switch is closed. Where we have to find out that at t equal to 0.5. That's why we have to be estimate I of t after t equal to 0. After t equal to 0, circuit you can take like this. For t greater than 0, switch is what? Closed. Now under this instant, what can be neglected? We can neglect this 5 ohms resistor. Now current is coming like this. What? 10 amperes is coming like this. Here 10 amperes. But here IL of t is also coming. Remember that. That's why total current, how you have to be considered? We need to be considered here to estimate the value of I of t. This is IL of t. This is 10 amperes. Now by KCL at x point, you can get it. 10 is incoming, which is equal to I of t is outgoing and IL of t is also outgoing. With that, I of t is equal to 10 minus IL of t, where IL of t is what? After t equal to 0, by making this a short circuit, is inductor is affecting with the current source? No, it is not affecting. Once if it is not affecting, this will come under what? Source free circuit, no? It will come under source free circuit. For source free circuit, I can take it I naught into e to the power minus t by tau. I naught value 5. Tau value how much? L by R. 1 by 2 minus 2t. This is the way how you have to practice. 5 into e power minus 2t. Now at t equal to 0.5, we can take it 10 into 5 into e power minus 1. This is what? At t equal to 0.5. Is it right? Now what we are getting from this? From this, you will get it I of t is equal to 10 into 5 into 0.368 now? Yes or no? 10 minus 5 into is what? 1.34 you are getting now. With this 8 point, how much you are getting that? 8.66 or 8.16. 40, 34, 15. 15 means 1.15 plus 3, 1.84. 1.84 means what we are getting that? 1.84 means 8.16 amperes. Is it given? 8.16 x. It is given 8.16. Option B is the correct one. This is the way how you have to get it. This is the way how you have to get it this, right? By KCL for this one you will get it. By KCL for this one you will get it, right? This is the question in the previous gate examination, right? This is the way how you have to practice. Guys, I think now you are perfect with this. Now you are perfect with the transient circuit analysis. And the transient circuit analysis, once you see this, from the starting onwards here, whatever we have considered this is the introduction and transient response, classification, source free circuits with source circuits, how the time instants, these are the time instants, this is very important for you. While coming to this one, behavior of RLC and final how you have taken at t equal to 0 plus at t equal to infinity, and source free circuits. For RL I have explained. Similar way we can get it RC, right? Similar way we can get it RC, and universal formula I have given. And for second order circuits, at t equal to 0, at t equal to infinity, circuit nature is resistive, responses are fixed. One example I have considered, this is the example, directly you can do it. And after that second order for t greater than 0, definitely we need to go for what? Laplace transformation. This is the conversion of Laplace from t domain to s domain under electrical circuit analysis. And special cases, impulse. When you will get impulse, when the violation of KVL and KCL, definitely we should go for that at t equal to 0 plus. This is usually you may identify for ideal inductors, ideal capacitors. Remember that. For ideal inductors, conservation of what? Flux linkage. For ideal capacitors, conservation of, this is the flux conservation, flux linkage conservation. This is for what? Charge conservation, right? These are very, very important, right? With this, I think you will have an idea regarding the transient circuit analysis, okay? This is about the transient circuits. Briefly, I have given here. Detailedly, if you want to get it, definitely you enroll with that ACE online. Definitely, each and every point I have discussed. Here, within 1.5 hours, if you want to show me entire thing means, it will take time. And I have taken quickly, one by one. That's why totally, if you want to cover that, each and every point, each and every single point, I have covered in ACE online classes. Once you enroll with that, definitely you will get the total picture about the transients. Even though under transient, for second order circuits, how you have to find out the time constant. For over damping, under damping, critically damping, undamped condition, how the time constant for second order circuits, I have provided in that one. Try to enroll with that ACE online, then definitely you will get the clear picture about the transient circuit analysis, right? Once again, I will come with that one more topic, then definitely you will get the more knowledge and get the subscription with the ACE online and get the full content for each and every subject, get the good rank in ESC as well as GATE examination. All the best. Thank you. Good night. Hmm?